On the morning of June 6, 1944, Allied forces stormed the beaches of Normandy in the largest amphibious invasion in history. But landing soldiers on a hostile beach was only the beginning of the challenge. The real test would come in the hours, days, and weeks that followed. How do you supply an entire army when there are no ports? How do you unload thousands of tons of equipment, vehicles, ammunition, food, and fuel onto an open beach exposed to the elements and enemy fire? The answer lay in one of the most extraordinary engineering accomplishments of World War II. American engineers, working alongside their British counterparts, would quite literally turn beaches into ports. This is the story of how they did it. The problem was obvious from the start of planning for Operation Overlord. The Germans controlled all major port facilities along the French coast. Capturing a deep-water port intact would be nearly impossible. The Germans would either defend it to the death or destroy it before retreating. The Allies had learned this lesson the hard way at American 1942, where a disastrous raid resulted in massive casualties. Even if a port could be taken, it would likely be so heavily damaged as to be useless for months. The invasion planners faced a seemingly impossible dilemma. They needed port capacity equivalent to a major city to supply millions of troops, but they had no ports. The solution was radical. Build artificial harbors. Not small temporary structures, but massive installations capable of handling the cargo capacity of major ports like Dover or Southampton. The British would develop the Mulberry Harbour's prefabricated portable harbours that could be towed across the English Channel and assembled on the Normandy coast. Meanwhile, American engineers would focus on a complementary system, turning the beaches themselves into efficient unloading zones, using innovative equipment, techniques, and sheer determination. The scale of the undertaking was staggering. In the first few days alone, the Allies planned to land over 150,000 men. Within weeks, they would need to sustain an army of millions. The men tasked with this impossible mission were the U.S. Army engineers, specifically the Engineer Special Brigades. These were not ordinary construction units. They were amphibious warfare specialists, trained to operate in the chaotic zone between sea and land. The Engineer Special Brigades combined engineering expertise with combat training. They would hit the beaches alongside the infantry, often under heavy fire, and immediately begin the work of organizing the beachhead. Their mission was to create order from chaos, to transform a battle zone into a functioning port facility, while fighting was still raging nearby. The preparations began long before D-Day. In England, American engineers studied every aspect of the Normandy coastline using aerial reconnaissance photographs, French tourism brochures from before the war, and intelligence reports. They analyzed tides, beach gradients, soil composition, and obstacles. They built scale models and conducted rehearsals on beaches in southern England that resembled the Normandy coast. Mock invasions were staged repeatedly, with engineers practicing their procedures until they could perform them under the most adverse conditions. Everything had to be planned down to the smallest detail because there would be no second chances. The engineers assembled an extraordinary array of specialized equipment. Much of it had been designed specifically for this operation. There were amphibious trucks, the famous DUKWs, or ducks that could drive off landing craft into the water, swim to shore, and then drive inland with their cargo. There were amphibious trailers that could be towed behind trucks through the surf. Bulldozers were waterproofed so they could operate in shallow water. Cranes were mounted on floating platforms. Everything was designed to function in the unique environment of the beach, where land and sea met. One of the most important innovations was the steel mat roadway system. The beaches of Normandy were not solid surfaces. They were sand and shingle that would quickly turn to mud under the weight of heavy vehicles and the churning of thousands of boots. Engineers brought with them thousands of rolls of heavy steel matting, essentially portable roadways that could be rolled out across the sand. These mats, called Sommerfeld track or pierced steel planking, created instant roads where none existed. They allowed trucks, tanks, and artillery to move off the beach without becoming bogged down. Laying these mats under fire was exhausting, dangerous work, but it was absolutely essential. The engineers also brought pontoon causeways, floating piers that could be assembled rapidly in the surf zone. These remarkable structures were made of steel and concrete pontoons that could be linked together and anchored to the seabed. Ships and landing craft could pull alongside these floating piers and unload directly, rather than having to beach themselves. This dramatically increased efficiency and reduced the vulnerability of ships to enemy fire, as they could unload and depart quickly. The causeways extended hundreds of feet out from the beach, creating instant deep water access where the shore was too shallow for larger vessels. On D-Day itself, the engineers went in with the assault waves. At Omaha Beach, where American forces faced the bloodiest fighting, engineer battalions suffered casualties as high as any infantry unit. They landed under intense German machine gun and artillery fire, tasked with clearing obstacles, marking paths through minefields, and beginning the beach organization even as the battle raged. Men worked waist-deep in water, often under fire, attaching explosive charges to the steel and concrete obstacles the Germans had placed below the tide line. It was terrifying, deadly work. Many engineers were killed or wounded within minutes of landing. Despite the chaos and casualties, the engineers began their work immediately. As soon as gaps were cleared through the obstacles, they marked safe lanes with colored flags and signs. They used tape to mark areas that had been cleared of mines. Bulldozers driven by engineers carved paths up the bluffs, creating exits from the beach. All of this happened while German positions on the heights above were still firing down on the beach. The engineers' motto was "Essayons, let us try." On D-Day, they proved that motto meant something. Without their immediate work under fire, the invasion might have stalled on the beaches. Once the immediate beachhead was secured, the massive task of beach organization began. The engineer special brigades divided the beaches into sections, each with specific functions. There were areas designated for vehicle assembly, ammunition dumps, fuel storage, casualty evacuation, and prisoner of war collection. Signs went up everywhere, directing traffic and identifying units. It was like building a small city overnight, except this city was on a beach, under occasional shell fire, and had to handle the cargo equivalent of a major seaport. The engineers established traffic control points, created parking areas, and organized salvage operations for damaged equipment. The statistics are staggering. Within the first week after D-Day, American engineers on the beaches helped unload over 100,000 troops and 14,000 vehicles at Omaha Beach alone. By the end of June, the beaches were handling 20,000 tons of supplies per day, more cargo than many major ports handled in peacetime. Ships arrived continuously, day and night. Landing craft shuttled back and forth. DUKWs drove into the water, loaded cargo, and drove back to shore. The beaches became assembly lines of men and material, with the engineers acting as the foremen of this massive operation. Every movement was choreographed to avoid congestion and maximize efficiency. Weather was a constant enemy. A major storm struck Normandy on June 19, 1944, lasting 3 days and causing enormous damage. The American Mulberry Harbor at Omaha Beach was completely destroyed. Ships broke loose from their moorings and were driven onto the beach. The carefully organized beach areas were thrown into chaos by waves and wind. But the engineers adapted. Without the artificial harbor, they doubled down on direct beach unloading. They salvaged what they could from wrecked vessels. They reinforced causeways and rebuilt roadways. Within days, they had not only recovered but actually exceeded their previous unloading rates. The storm proved that the American approach, flexible, improvised beach operations, was perhaps more resilient than the elaborate Mulberry harbors. The engineers developed innovations on the fly. One problem was unloading ships at low tide when landing craft couldn't reach the shore. Engineers created rhino ferries, large floating platforms made from pontoon sections, powered by outboard motors. These could operate in very shallow water and carry vehicles and cargo between ships and the beach. Another innovation was the use of captured German equipment. Engineers would repair damaged German trucks, cranes, and locomotives, and put them to work in the supply effort. Nothing was wasted. Even destroyed vehicles were salvaged for parts. Fuel was a special challenge. An army runs on gasoline, and the Allied forces in Normandy were consuming fuel at an enormous rate, hundreds of thousands of gallons per day. Engineers laid flexible pipelines across the beaches and inland, creating a network called the Red Ball Express's fuel line. They also developed a system called Pluto Pipeline under the ocean, which pumped fuel directly from England to France through underwater pipelines. At the beaches, engineers set up fuel dumps with thousands of jerrycans and larger storage tanks. They created refueling points where vehicles could quickly fill up before moving inland. The logistics of fuel alone required extraordinary engineering and organization. The engineer units worked around the clock in rotating shifts. There was no pause in operations. Supplies were needed constantly. Men worked in the rain, in the dark, in the cold. They waded through surf, operated machinery, directed traffic, and solved endless problems. Fatigue was constant. So was danger. German artillery would occasionally shell the beaches. Luftwaffe aircraft, though increasingly rare, would strafe supply dumps. Mines, both on land and in the water, remained a constant threat. Engineers were killed and wounded throughout the Normandy campaign, not in dramatic battles, but in the grinding, essential work of keeping the supplies flowing. The experience gained in Normandy was applied to every subsequent amphibious operation. In the Mediterranean, American engineers had already been perfecting these techniques during landings in North Africa, Sicily, and Italy. Each operation taught new lessons. Engineers learned how to deal with different types of beaches, rocky shores, mudflats, coral reefs. They adapted their equipment and procedures to local conditions. The body of knowledge grew with each landing. By 1944, the U.S. Army had become the world's expert in amphibious logistics. No other nation could match their capability to land an army on a hostile shore and keep it supplied. In the Pacific theater, American engineers faced even greater challenges. The distances were vast, thousands of miles of ocean-separated bases. Many Pacific islands had no beaches at all, just coral reefs and volcanic rock. The Japanese were skilled at fortifying islands, turning them into deadly fortresses. Yet American engineers found solutions. At Tarawa in November 1943, the assault nearly failed when landing craft couldn't cross the coral reef at low tide. Marines had to wade hundreds of yards under fire. Engineers learned from this disaster. They developed specialized equipment for coral environments, including reef blasting techniques and tracked landing vehicles that could crawl over coral. At Iwo Jima in February 1945, engineers faced a unique problem: volcanic sand. The beaches were steep and made of fine black ash that gave way under the weight of vehicles. Trucks and even tracked vehicles became stuck immediately upon landing. Engineers worked frantically to create roads using the steel matting. But the volcanic sand was so fine, it worked its way into everything: engines, weapons, food. They also had to operate under fire from Japanese positions in caves on Mount Suribachi and throughout the island. Despite these challenges, engineers managed to establish a functioning supply system, and Iwo Jima's airfields, the reason for capturing the island, were operational within days. Okinawa, the last major amphibious operation of the war, saw the culmination of American beach engineering expertise. The invasion in April 1945 involved landing 4 divisions simultaneously on multiple beaches. Engineers had the operation down to a science by this point. Within hours of the initial landing, they had causeways extended, roads marked, and supply dumps organized. Within days, they had functioning ports at the beaches, handling thousands of tons of supplies. The efficiency was remarkable considering they were building these facilities from scratch on enemy-held territory. The lessons learned over 4 years of war had created a system that worked like clockwork. The engineering innovations developed during World War II had lasting impact. The concept of rapidly establishing logistics over a beach rather than relying on capturing ports intact revolutionized amphibious warfare. The equipment developed: DUKWs, pontoon systems, steel matting. Amphibious vehicles remained in use for decades after the war. The U.S. military's capability in amphibious logistics gave it enormous strategic flexibility. American forces could land anywhere, not just at established ports. This capability would prove valuable in Korea, Vietnam, and later conflicts. The legacy of those World War II engineers continues today. Perhaps most remarkably, the engineers accomplished all of this while also fighting as combat troops when necessary. Engineer units in World War II were trained infantry as well as technicians. They defended the beaches against counterattacks, they cleared bunkers, they fought house to house in French towns. The 6th Engineer Special Brigade, for example, fought as infantry during the Battle of the Bulge, when German forces threatened to break through American lines. Engineers were versatile troops who could build a bridge in the morning, unload ships in the afternoon, and man a defensive position at night. This versatility made them invaluable. The personalities behind this achievement were as varied as America itself. The Engineer Special Brigades drew men from every background: farmers who understood machinery, construction workers who knew building, dock workers who understood cargo handling, and college-educated engineers who could solve complex technical problems. Many engineer officers were civilian engineers before the war, men who had built bridges, roads, and dams during the Depression years. They brought practical experience that proved invaluable. The non-commissioned officers, the sergeants and corporals, were often the key to success, men who could organize work parties, motivate exhausted troops, and improvise solutions to unexpected problems. One notable figure was Colonel Eugene Caffey, who commanded the 1st Engineer Special Brigade at Omaha Beach. Caffey was a West Point graduate and career Army officer who had helped develop the doctrine and training for amphibious engineers. On D-Day, he landed with his troops and spent the day moving along the beach under fire, directing operations and solving problems as they arose. When his headquarters was hit by German artillery, killing several of his staff, Caffey continued directing operations without pause. His leadership helped turn chaos into order during those critical first hours. Men like Caffey represented the professionalism and dedication that made the engineer operations successful. The rank-and-file engineers deserve equal recognition. These were ordinary men, teenagers, and young adults, many experiencing their first time away from home, thrown into extraordinary circumstances. They worked until they dropped from exhaustion, then got up and worked some more. They took pride in their work, competing between units to see who could unload the most ships or clear the most beach obstacles. The esprit de corps in engineer units was strong. They knew their work wasn't glamorous. They weren't infantry storming enemy positions or pilots shooting down enemy aircraft, but they knew it was essential. Without them, the combat troops couldn't fight. They were the unsung heroes who made victory possible. The human cost should not be forgotten. Engineer units suffered significant casualties throughout the war. At Omaha Beach, the 6th Engineer Special Brigade lost 10% of its strength on D-Day alone, over 250 men killed or wounded. In the Pacific, engineers faced not only enemy fire but also tropical diseases, accidents with heavy equipment, and the psychological toll of months-long campaigns. Some men were lost to drowning in the surf while working on causeways. Others were killed by mines they were trying to clear. The work was dangerous in ways that aren't always obvious in the historical record. These men paid a real price for their service. The logistics achievement represented by these beach operations is difficult to overstate. Consider that the Allied armies in Northwest Europe required roughly 600 tons of supplies per division per day. With dozens of divisions in theater, this meant tens of thousands of tons of supplies daily every single day. Without fail. All of this had to come across those beaches for months until proper ports could be captured and repaired. The American beaches in Normandy alone handled over 2 million tons of supplies and 800,000 vehicles in the first 4 months after D-Day. This was accomplished with temporary facilities built under fire on an enemy-held coast. It remains one of the greatest logistical achievements in military history. The beaches themselves tell the story decades later. Visit Omaha Beach or Utah Beach today, and you can still see remnants of the artificial harbor's concrete blocks in the water, rusted metal fragments half buried in sand. The beaches are peaceful now, popular with tourists and locals, but the history is still there. At low tide, you can see the posts and obstacles that engineers cleared under fire. You can walk the distance from water's edge to the bluffs and understand the challenge they faced. Museums along the Norman coast preserve the equipment: DUKWs, pontoon sections, steel matting that made the transformation of beaches into ports possible. These artifacts are testimony to American engineering, ingenuity, and determination. The broader lesson of this story is about problem-solving and adaptation. The American military in World War II faced problems that had never been solved before. How do you supply an army without a port? The answer wasn't found in any manual or textbook, it had to be invented. American engineers, given the mission and the resources, figured it out through innovation, hard work, and determination. They combined existing technologies in new ways, invented new equipment where needed, and most importantly, adapted their plans when circumstances changed. The great storm that destroyed the Mulberry Harbor could have been a disaster. Instead, engineers adapted and actually improved their performance. This flexibility and ingenuity represent something fundamental about the American approach to war. The transformation of beaches into ports also represents the American industrial and economic advantage in World War II. The equipment used thousands of specialized vehicles, millions of tons of steel matting and pontoon sections, endless supplies of fuel and materials, could only be produced by a fully mobilized industrial economy. America's factories worked around the clock to build the landing craft, the trucks, the bulldozers, and all the other equipment that made these operations possible. American shipyards launched new vessels faster than the Germans could sink them. This industrial capacity, combined with the skill and dedication of the engineers who used the equipment, proved decisive. Germany and Japan simply couldn't match this combination of industrial might and technical expertise. Training was another key factor. The U.S. Army invested heavily in training engineer units, specifically for amphibious operations. Special bases were established in the United States where engineer brigades practiced their procedures repeatedly. They trained on beaches in California, Florida, and Massachusetts. They rehearsed in all weather conditions. They learned to work with Navy units, coordinating the transfer of supplies from ship to shore. This training paid enormous dividends when the real operations began. The engineers at Normandy weren't improvising from scratch. They were executing procedures they had practiced dozens of times. The training regimen developed during the war became the model for training amphibious units for decades afterward. Inter-service cooperation was essential to success. The engineer special brigades operated in the space between the Navy and the Army. They worked on landing craft operated by Navy crews. They coordinated with Navy beach battalions. They communicated with transport ships offshore, directing them when and where to unload. This required clear communication and mutual respect between services that had traditionally operated independently. The fact that this cooperation worked so well is a credit to the leadership of both services. Personal relationships mattered. Engineer officers and Navy officers who trained together, planned together, and fought together developed trust and understanding that made operations run smoothly. The story of turning beaches into ports is ultimately a human story. It's about men who were asked to do something extraordinarily difficult and who refused to accept failure. It's about leadership at every level: generals who planned the operations, colonels who commanded the brigades, captains who led companies, sergeants who organized work parties, and privates who did the actual backbreaking labor. These men came from every part of America and brought different skills and backgrounds, but they shared a common purpose. They understood that their work, unglamorous as it was, made victory possible. The infantry couldn't advance without ammunition. The tanks couldn't move without fuel. The wounded couldn't survive without medical supplies. Everything depended on keeping the supplies flowing across those beaches. The engineering achievement at Normandy and across the Pacific demonstrates that wars are won not just by brave soldiers, but by the entire support system that keeps those soldiers equipped, fed, and supplied. For every combat soldier at the front, there were many more in the rear handling logistics. The engineers who turned beaches into ports were force multipliers. Their work enabled the combat units to operate effectively. Modern military doctrine recognizes this reality explicitly, but it was proven in practice during World War II. The sophistication of the logistics system developed by American engineers gave Allied forces an enormous advantage. German commanders frequently commented on the abundance of American supplies and the apparent ease with which they were delivered even in difficult circumstances. After the war, many of the engineers who had performed these remarkable feats returned to civilian life and applied their skills to peacetime construction. They built America's interstate highway system, bridges, dams, and cities. The organizational skills, the ability to manage large projects, and the experience working under pressure all translated to civilian careers. Some became construction company executives. Others became civil engineers working for state governments. A few became professors, teaching new generations of engineers. They carried with them the lessons learned on the beaches of Normandy and the Pacific lessons about solving problems, adapting to circumstances, and never giving up. The equipment they developed lived on as well. DUKWs remained in military use through the Vietnam War, and even saw civilian use as tourist boats in several cities. Pontoon bridging systems based on World War II designs are still used by military engineers today. The steel matting developed for beaches became standard for temporary roads, runways, and helicopter pads. The lessons learned about beach gradients, tide tables, and soil-bearing capacity became part of standard military engineering doctrine. In a real sense, every modern amphibious operation owes a debt to the World War II engineers who first figured out how to turn beaches into ports. Their innovations became the foundation for everything that followed. In the end, the story of American engineers turning beaches into ports is a story about overcoming the impossible. When planners first considered the problem how to supply millions of troops without a port, many thought it couldn't be done. The scale was too large, the challenges too great, but American engineers proved the skeptics wrong. Through innovation, determination, industrial capacity, and sheer hard work, they created a logistics system from nothing. They built ports where no ports existed. They sustained armies in the field despite every obstacle the enemy, the terrain, and the weather could throw at them. It was an engineering triumph that ranks among the greatest achievements of World War II, and it demonstrates what can be accomplished when skilled, dedicated people refuse to accept that something is impossible. Thanks for watching. The Engineer Special Brigades, and the men who served in them, deserve to be remembered alongside the infantry, the airmen, and the sailors who get more attention in popular accounts of World War II. Their contribution was absolutely essential to victory. Without them, the great military campaigns that defeated Nazi Germany and Imperial Japan would not have been possible. They were the men who made logistics an art form, who turned chaos into order, and who proved that American ingenuity and determination could solve any problem. The next time you see footage of D-Day or read about the Pacific Island campaigns, remember the engineers who were there, often invisible in the historical record, doing the essential work that made victory possible. Please subscribe and share.